Welcome to 8b, which is simplify and multiply and divide radical expressions. In class we did some simplifying and some of you actually did multiplying, but I'll run through them quickly again anyways. To simplify the square root of 50, you can do it two ways. The one way is to figure out what perfect square divides into 50 evenly. So you'd think 25 is a perfect square, and that's times 2. And the square root of 25 is 5. Square root of 2. Square root of 2 left over, so it's 5 square root of 2. You could do that, or you could do the trees. Tree it out with the greatest common factor, or what times what equals 50. I circle the prime numbers. And then we look for, since it is a square root, so it's square root 2, we look for pairs, and I have a pair of 5s here. So that pair of 5s would come out as just one 5, like it is here. And then a 2, there's no pair for a 2, so it stays underneath the radical. So you can do it either way, it does not matter. I'm going to do it the first way. So we have square root of 72. What perfect square can divide into 72? So perfect squares, you got to think of 4, 9, 16, 25, 36, 49, 64, just keep going. It never end. The biggest perfect square that divides into 72 that I can think of is 36. So square root of 36 is 6. And then square root of x to the third, how many pairs of can you get out of 3x's? That's 1. And then, so 36 divided by, or 72 divided by 36 is 2. And there's an x left over. Nothing to simplify here, so this is it. Again, you can do these with the trees if you want it. It's not a big deal if you do, it's just a little slower. Alright, on to cube roots. Cube root of 80. So now with cube roots, you gotta think of perfect cubes. So like 2 to the third, that's 8. 3 to the third, that's 27. 4 to the third, and that's 64. 5 to the third, maybe you might have to go up that high. Doubtful that you'd ever have to go 6 to the third, but if you remember these 4 for cubes, makes it a lot easier. So 80, which one of these would divide, or could you divide by 80, and that would be 8. So we have the cube root of 80, we have 2 on the outside, cube root of 8 is 2, there's a 10 left on the inside, but I'm going to deal with the variables next. So n to the 5th, there's 5 n's. How many groups of 3 can I take out of 5? 1. And then what's left over. So 80 divided by 8 is 10. And then there were 3 n's that we took out to make this one n. And the cube root of n to the third is n. And then there are 2 n's left over. Again, can be done with the trees. Next, we have cube root of negative, don't forget this negative 16, x to the 7th, y to the 8th. Now, there's also, with these numbers up here, these perfect cubes, 2 to the third, 3 to the third, 4 to the third, 5 to the third, there's also what would be negative 2 to the third. Well, that's negative 8. And negative 3 to the third, that's negative 27. Negative 4 to the third, that's negative 64, and so on. So with squares, perfect squares, you don't have to worry about negatives because negative 2 squared is 4, positive 4, just like 2 squared is 4. Or negative 4 squared is 16, just like 4 squared is 16. They're both equal to positive. Well, it doesn't happen with negatives or with cubed, because it's multiplying it out 3 times. When you multiply a negative 3 times, you're going to get a negative. So, thinking about that, now we think cube root of negative 16. Which one is going to be here? Anytime it's negative underneath the cube root, let's divide by negative 8. So the cube root of negative 16 is negative 2. And we have x to the 7th, cube root of that. You can simplify down to x squared. So that's 3 groups, or 2 groups of 3 out of the 7. And how many groups of 3 can I make out of 8? There's 2 more there. That's y. So let's get y in here. Y squared. And then we have cube root. It was negative 16 divided by negative 8 is positive 2. And then we had 2 groups of x's that came out, leaving us with 1x, because it was x is 6. Cube root of x is 6 is x squared. And y's, there should be 2 y's left. And nothing to simplify anymore. So this is the answer. That's the simplified form. Alright, with multiplication. So there's multiplication between these two. To multiply, you have to have the same radical. Other than that, you can multiply. So if you have the same radical, you can multiply. So all you do, it's a 4th root, so it stays the 4th root. And so we have 4 times 8, 32. X to the 5th times x to the 7th. X to the 12th. Y to the 7th times y to the 2nd. Y to the 9th. Z to the 6th times z to the 3rd is z to the 9th. And now, I know the original directions are to simplify. I wouldn't simplify first. I'd multiply first, because now we have one expression that we can simplify, rather than 2 separate ones. If you simplify first, then you'd have to multiply and simplify again. So I always multiply, then I simplify, and then you're done. So simplifying this, 4th root of 32. So let's think what 2 to the 4th is. 2 times 2 times 2 times 2 is 16. So 2 to the 4th is 16, so 4th root of 16 is 2. So let's take a 2 out of the 32. How many groups of 12 can I make out of, or how many groups of 4 can I make out of 12? So there's x to the 3rd, you got y, you got 2 groups of y's that can come out, and z, there's 2 groups. So z, 4th root, let's figure out what's left over. So 32 divided by 16 is 2. X's are all used up with the 3 groups. Y's, there's 1 group left over, or 1 y left over. Z, there's also 1 left over. So here's the simplified form. Alright, moving on to multiply, or division. So we have, in this case, we have cube root of 2 divided by the cube root of 3x. This is there's 2 different divisions that we have to work with. This is a monomial denominator with a monomial. So when it's a monomial, all you do is you just multiply by that monomial. So this is a denominator, is a monomial, and we have, this is a cube root. So when it is a cube root, what you're going to do is you're going to end up multiplying by 2 more sets, 2 more of the denominator, the cube root of 3x. And what you do on the denominator, you're going to have to do it on the numerator. So multiply by 1, cube root over 3x, over the cube root of 3x, and 1 more. And by doing this, we multiply out the numerator, so they're all cube roots, so we just multiply underneath the radical. So 2 times 3x, 6x times another 3x is cube root of 18x squared. In the denominator, we have cube root of 3 of the exact same things. After a little bit, you're going to be able to skip this step I'm going to do, but right now, you do 3x times 3x times 3x, and that's a cube root of 27x to the 3rd. When we go to simplify this, cube root of 18 in the numerator, cannot simplify. Cube root of x squared cannot simplify. So we're trying to simplify now. In the denominator, you can cube root of 27 is 3. Cube root of x to the third is x. Look to the numerator and denominator, see if there's anything numerator and denominator that you can simplify, and there's not. You cannot simplify outside of the radical with stuff inside the radical. And that's it. But this was a square root, so let's say this problem was square root of 2 over square root of 3x, so it's a square root, not a cube root. What you're going to do is you'd only multiply by one more of the denominator. Reason why: cube root of 2 times cube root, or square root of 2 times square root of 3x is square root of 6x, and here's the reason. When you multiply out the denominator, 3x times 3x is 9x squared. You have the numerator does not simplify, but the denominator here simplifies down nicely. Square root of 9 is 3, square root of x squared is x, and that's your whole goal, is to get the denominator without a radical. That is in simplified form. You have to have no radical left in the denominator for it to be simplified. So nothing left in the denominator and it's simplified, no radical in the denominator. Now, when you have two terms, so this is a binomial denominator, a binomial, oh man, that's some bad writing. Binomial denominator. When you have that, what you're going to end up doing, it's a square root, so we're only going to multiply by one more. And what you're going to do is, this is a positive square root, so what we're going to do is you switch the sign. You multiply by the whole denominator, just switch the sign of the radical. Always the radical, not necessarily the middle or the sign that you see. This is a positive square root of 5, or square root of 5x squared, so it's a subtraction there. If these two terms were switched, it would be a negative square root of 5, or square root of 5x squared, plus 2 is what you would multiply by. But now we have a monomial times a binomial, so I like to put the binomials in parentheses to remind myself that I need to distribute. So that's 6x, distribute 3x to the radical, and so it's on the outside. And in the denominator, we have a binomial times a binomial. So we multiply it out, 2 times 2 is 4. 2 times a negative square root of 5x squared. And then 5x square root of 5x squared times 2. 2 square root of 5x squared. And square root of 5x squared times a negative 5x squared. Square root 25x to the fourth. Put that in there. Yes. Alright. Let's simplify everything. Let's start with the numerator. Don't fall for it. You can't do 6x minus 3x because this is not just 3x. This is 3x squared of 5x squared. Only thing I can simplify, I see I have a square root of 5x squared, so let's simplify that. So I have the 6x minus 3. Let's try that 3 again. 3 x square root of x squared is x. X times x, x squared. Square root of 5 I cannot simplify. In the denominator, we have 4 minus 5 square 2 square root of 5x squared plus 2 square root of 5x squared. Negative, positive, those will cancel out. So we have a 4. And then we have a subtracting 25x to the fourth, square root of that, it is 5x squared. And we look to see if there's anything. We have 4 terms, so all 4 terms have to have something in common for you to simplify. This has x, 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 but the 4 does not have an x, so it does not simplify. And there's no square roots left in the denominator, so therefore this is it. Come to class with any questions. Apologize for it being 15 minutes, but it's good stuff to know.